students, now we are doing another important example. Find the equation of straight line passing through the point 1 minus 3 2 and it's perpendicular to the lines this and this. Now its solution is equation of straight line through the point 1 minus 3 2 is x minus 1 upon a, y minus 3 upon b is equal to z minus 2 upon c. This is a equation of straight line passing through points. Now on solving this we get this. Now this lines is perpendicular to both the given lines, so direction cosines of this lines and this lines is equal to multiply is equal to 0, and similarly direction cosine of this and this is equal to 0. Now given lines are these two lines. Since first equation of lines is perpendicular to 2 and 3, so a into 1, v into 2, c into 3. A into 1, b into 2, 3 into c is equal to 0. Since these two equations are perpendicular to each other, so their direction cosine is product of direction cosine is equal to 0. Similarly, in these lines 3 into a, 2 into v and 3 into c is equal to 0. From this we get 0 since product of their respective direction cosines is equal to 0. Now we solving the equation 4 and 5 by using the formula 2, 3, 1, 12. Here 2 is a coefficient of both the equation, coefficient of b, and 3 is coefficient of c, and 1 is coefficient of a, and similarly 2 is coefficient of v. Now b here write the coefficient of b. B coefficient is 2 and here b coefficient is 2, and similarly coefficient of c here is 3 and here is 5, 3, 5, and coefficient of a is 1 and here coefficient is minus 3, and similarly coefficient of 2 is repeat 2, 2. Now solving this, a upon multiply diagonal element 2 into 5 is equal to 10, minus of diagonal element 2 into 3 6, and is equal to b upon 3 into minus 3 diagonal element minus 9, and multiply of diagonal element 5 into 1 is equal to minus 5. Minus is from formula, and similarly c upon 1 into 2 2, and minus 3 into 2 is equal to minus 6, and here minus is from the formula. On solving this we get a upon 4, b upon minus 14, and c upon 8. On solving this we get 2 minus 7 minus 4. Now we have value of a 2, b minus 7, and c 4. This putting this value in equation 1, which is the required equation. X minus 1 upon a is equal to y plus 3 upon b is equal to z minus 2 upon c. Now putting the value of a, b and c from this 2 minus 7 minus 4. This is a required equation of plane and straight line. Now there is another important example. A variable plane which is at a flowing distance from the origin meet the axis at a, b, c respectively. Show that the locus of the centroid of a triangle ABC as below. Distance 6p locus is equal to 1 upon x square plus 1 upon y square plus 1 upon z square is equal to 1 upon 4 p square. Now its solution is let OA is equal to A, OV is equal to V, or OC is equal to C. Here is the x-axis, or OA is equal to A. Here is only x coordinate. Y or z is 0. Now, similarly, OV is equal to V. Here x and z coordinate 0. And this is the origin 0, 0, 0. All x, y, z coordinate 0. Now there is a OC whose x, y coordinate 0 and C, O to C value is C. Now the equation of plane is x upon a, y upon b plus z upon c is equal to 1. This is the equation of plane. Now we're taking minus 1 upon these sides. Now this one x upon a plus y upon b plus z upon c minus 1 is equal to 0. Now distance of equation 1 from the origin 0, 0, 0 is equal to 6p. This is given. Now we putting this value in the distance formula. Value of x is 0, y is 0 and z is 0. We get this magnitude 0 plus 0 plus 0 is minus 1 on this equation. Now here is square root of coefficient of x1 1 upon a square, coefficient of y1 by 1 upon b square, and coefficient of z 1 upon c square is equal to 6b. 6b is a given distance from the origin. By inversing and taking the square both sides, we solving this 1 upon a square plus 1 upon b square plus 1 upon c square is equal to 1 upon 36b square by taking inverse and square. Now the centroid of a triangle is a upon 3, b upon 3, c upon 3. For its locus, replace a upon 3 by x, b upon 3 by y, and c upon 3 by z. That is, a is replaced by 3x, b is replaced by 3y, or c is replaced by 3z. Then the equation 1 upon a square 1 upon b square plus 1 upon c square is equal to 1 upon 36b square become. Here we put a square, a's value is 3x and a square is 9x square, and similarly v value is 3y and b square value is 9y square. Similarly 1 upon 9 z square is equal to 1 upon 36 p square. On solving this, we take a common 9s, and 9 is divided by 36 is equal to 4. Now we solving this, we get 1 upon x square 1 upon plus 1 upon y square plus 1 upon z square is equal to 1 upon 4 p square, which is proofs. Thanks students for attending this lecture.